Hello everyone. In this video, I want to talk a little bit more about what the file cursor is and how you can use it to help understand processing files. I also want to work another example that's slightly more complicated than our transactions.txt example. So let's head over to the notes and start working on our warm-up task. Go ahead and open a file called advancedfileiofun.cpp in gedit. I highly recommend that you put this inside of a directory, perhaps called Advanced File IO Fun, just like we did in our last video, our last example, just so we can keep our C++ file and our actual text files together and organized. Since we know we're going to use files in this example, let's go ahead and also include fstream while we're at it. So while we're in gedit, we're going to go ahead and make another file. This one's going to be the txt file we're going to use as input. It's going to be slightly more complicated than our transactions.txt, just so you can get more practice working with files. So let's go ahead and open another file in gedit, and let's call it students.txt. So we're going to put some basic information about a couple students in this file. They'll be fictional students, so go ahead and make up some fun names. We're going to provide 3 pieces of information about each student. We'll have the name of the student, the class standing, as well as the GPA. That way we get a little bit of a mixture of strings and numeric types. So I'm going to do an example for our first one that you can use as well, and then go ahead and add some more information about fictional students. So let's say we have a student called Jane Student, and her class standing is a freshman, and her GPA is 3.5. So here's 3 pieces of information about a single student. Now I'm going to press enter twice so that I'm on line number 5. I'm going to use a new line character in order to separate information about different students. It will make our file a little more easy to read. And when I say read, I don't necessarily mean in terms of programmatically read, I mean just in terms of visually reading it. Now go ahead and add some more info about students in the same format. The first line will have the name of the student, the second line will have the class standing, and the third line will have a numeric GPA. All right, I've just entered information for 3 students. So my file's not very long, but it's long enough that we can write some code in order to process it. So I want to take a moment and talk a little bit about something called the file cursor. Anytime you open up a file for reading using an ifstream variable, there is a cursor that marks the position in the file at which a stream extraction operator, or getline, will start reading from. When you open up a file, that position or that cursor is always at the beginning of the file. I like to think about it as when you open up a new file in gedit. For example, if we were to open up advancedfileFun.cpp, the cursor would start at the beginning of the file. Think about that cursor in gedit just like a cursor that's used by your program in order to read values from a file. It starts at the beginning, and as you consume input or extract input from the file, like reading in Jane student, the cursor advances. And as it advances through the file, it eventually reaches the end of the file, and then there's no more advancement of the cursor, and that special state, EOF, is reached. If you ever need to move somewhere in the file that perhaps is not the immediate next value, maybe you want to move the cursor all the way back to the beginning of the file, you can do that with something called random access. We're not going to cover random access in this class, but there are a lot of advanced file I/O techniques that you can use, like random access or working with binary files. If you want to start learning about advanced file I/O techniques beyond what we're going to cover in this class, I recommend checking out Gaddis, Chapter 12, as your starting point. In this class, if you need to have your cursor back at the beginning of the file, then you'll have to close the file and reopen it. For example, this code here opens up transactions.txt, reads all the values from the file, then closes it, then opens it again and reads all of the values again from the file. So this is what you can do in order to reset your cursor back to the beginning of the file. Simply close and reopen it. But if you need to move somewhere in the file, like the halfway point of the file, for example, or you're searching for something specific, you'll want to take a look at some advanced file I/O techniques. But just closing our file and reopening it to reset our cursor is all we really need for this class. So now that we know a little bit about the file cursor and how it moves through from beginning to end in your file as you consume input from the file, let's go ahead and work through this example where we want to read the name, the class standing, and the GPA for each one of the students in the file. Based on your knowledge of our transactions.txt example, I think you're ready to be given a task in order to at least go through and read each one of these lines as a string. No need to try and figure out, is this the name, the class standing, or the GPA, or a blank line? Just go ahead and try to echo out all of the contents of this file to the console. So I'll give you that task. So go ahead and work on this task. Read each line from the file as a string and display it to the console. Go ahead and take a stab at this. I think it's good practice that every time you are working with a new file, you just write some really basic code that reads in each line of the file or each piece of information from the file as a string and echo it out to the console. That way you can kind of prove to yourself that you're successfully able to get some values from the file. And if everything works well, then you can prove to yourself you can get all values of the file. So right now, I have all values from the file being read, but they're not being specifically read in as, say, the name of a student, the class standing of a student, or a GPA. And for the GPA, I'd like to read that in as a floating point value, not as a string. Because if I wanted to figure out, for example, what is the average GPA of all the students in this file, I wouldn't be able to do that if the GPA is being stored as a string of characters instead of a numeric data type. So everything looks good here. A few things I'll want to note. Looks like our first and our last name is being broken up into two different tokens or pieces of information. That makes sense based on our knowledge of how the stream extraction operator works when we were working with it in CN. So right now, Jane and student is being broken up into two pieces of information. And then our new line characters are not being stored inside of our string value, which is okay. That's what we want. They're just there for whitespace separation reasons. So take a moment and think about how we fixed this problem before, where we wanted an entire line of text to be read in as one string instead of strings separated by spaces read in as individual strings. So how we fixed this was by using getline. And we can use getline with an ifstream variable as well. It's actually pretty cool. So let's do this. We know that our data is grouped into 3 lines: name, class standing, GPA, name, class standing, GPA, name, class standing, GPA. So each iteration of our loop, let's read in 3 values, one for the name, one for the class standing, and one for the GPA. So we're going to need to declare some variables, one to store the name, one to store the class standing, and one to store the GPA. I'm going to go ahead and replace the generic value with name. I'll also add a class standing and a GPA that's of double type. So I first want to read in the name because I know that's there first. And if everything went well reading in the name, I'm going to print out a custom label that says, this is the name. Now I do want to change this to use getline instead of the stream extraction operator so that the first name and the last name come in as one string. So we use getline, but instead of our first value before the comma being CN, it's going to be input file. Now I run this, and so far my name looks good for first and last name being one string. And I want to work next on getting the class standing. We can use getline or the stream extraction operator to get the class standing. It doesn't matter, since our class standings like freshman, sophomore, junior, senior are all one word. Every time we try to extract some information from the file, we should check to make sure that that extraction was successful with a call to input file.good. We want to call good before we try to do anything that uses that value. Okay, we're not quite done here, but we can at least see what this looks like. Okay, we've got our names. That looks good. And then class standing freshman, class standing senior, class standing sophomore. The only thing we have left to do is right now our GPA is being read in as a name, and that extra pesky new line character after the name is causing us to read in an empty string for class standing. All right, time for the GPA. We won't use getline this time because we want to read it in as a double. All right, let's see how this looks. All right, so we have name, Jane student, class standing freshman, GPA 3.5, and that looks good. But then it looks like our program is hanging. Name is seemingly an empty string, class standing is an empty string. What's going on here? Well, what's happening is when we use the stream extraction operator instead of the getline function to read in a value from the file, it leaves the new line character at the end of our GPA values in the buffer. So when we call getline on the next iteration of the loop in order to read the name in, that new line character is immediately encountered and the empty string is being stored in name, which makes everything slightly off by 1. So when we try to read in a GPA, there's not actually a double value there, it's a string. So we get a little off when we don't account for this pesky new line character at the end of our double values. We've seen this problem before when we were working with user input. When we start mixing the stream extraction operator and getline together, we start to get these new line character problems. But I know you know how to fix it because we've seen this problem before, just in a slightly different context, but we solve it the same way. We've got to get rid of that new line character at the end of GPA. So let's declare a temporary string. We don't have to. We could reuse name if we want, or class standing. But I think sometimes declaring a temporary string in order to just get rid of that new line character can be helpful and make our code a little more clear about why we're doing this. Okay, we've gotten rid of the new line character that's after the double value here. Let's run it and see what happens now. Okay, it looks like it's still hanging. So let's take a look back at the code, or excuse me, back at the students.txt file here. So we've got rid of this new line character that causes the input file to have this new line, but there's still a new line character here that causes the input file to have this Joe Schmo on a new line. So we've got to get rid of this extra new line that's in between our student information. So we've got these groups of student information, group here, group here, group here, and we separated them by a space. We've got to get rid of that space, which is a new line character. Now, the reason why we have to get rid of the new line character explicitly here, whereas in the very beginning, when we wrote this code, we didn't have to, is because this code didn't use the getline function. So the stream extraction operator will parse input based on any whitespace character, like a new line space or tab. Then when we switched over to using getline, getline only uses new line characters to separate tokens. So that's why we start to see these new line characters show up as blanks here. So just to explain why we have to do this weird new line buffer magic here, it's because we're using getline, and getline only looks for new line characters, and when it encounters a new line character, it stops processing input. That is not true of the stream extraction operator. All right, we've got name, class standing, GPA for the first student, name, class standing, GPA for the second student, name, class standing, and GPA for the third student. And all looks well here. So the moral of this video really is we have a file cursor, and the file cursor moves throughout our program as we extract data. Moves throughout our input file as we extract data from it. Now, the format of our input files can be simple, like transactions.txt, medium simple / complex, like our students.txt, or even crazy complex, like some other files. For example, if you were to try and open up, let's say, an image file, it would be in a much more complicated format than perhaps our students or our transactions.txt. So whenever the file is in a slightly different format, you want to learn that format and figure out how you can process perhaps groups of data in order to read information in from it. Lastly, when you mix the stream extraction operator and getline together, you kind of open the door to have these new line characters that are kind of sitting in the buffer, and you're going to have to write some code to accommodate those. So if you're ever working with files and it seems like things are slightly off, as you saw in our example, or it looks like the program is hanging, as you've also seen in our example, it's probably because you're trying to read some value from the file, perhaps as a string or a numeric value, that's not actually a string or a numeric value, or there's a new line character. So just make sure that everything is being accounted for as you process that file. Working with files now makes our programs a lot more powerful because we could write information to a file to save state data across our programs. For example, let's say we're writing up a game that has a high score. Now we have the ability to save a high score across different runs or different executions of our game. So let's say that your friend Joe plays the game on a Monday and he gets his high score of 1,000. And then your friend Mary plays the game a week later, maybe like Friday, Saturday, or Sunday, and she gets a score of 1,500. She will be able to see that her score is greater than Joe's score of 1,000 because your program could write that 1,000 out to file, read it in when Mary plays the game, and show Mary the current high score. Since Mary has a new high score, you could overwrite the 1,000 in your high score file and write that to disk such that next time, perhaps when Joe plays again, he'll see that there's been a new high score and he needs to spend more time playing your game to get better than Mary. So this really opens the door to a lot of different problems that we can solve. The game example is just one, but think back to our first video on File.io when we were talking about processing large databases of data, perhaps from a bank, for example. Now that you know how to read input in from a file and write output to a file, you could start working on some data science questions related to large data sets, like a bank data set.